Okay, continuing. In an earlier video, I described how you could imagine uh, a triangle with a very small angle, an angle very close to 0, or a triangle with an angle very close to 90 degrees, and use those triangles along with SOHCAHTOA to figure out what the sine of 0 is equal to and what the sine of pi over 2 is equal to. We could do the same thing for other special angles, like what is the sine of pi, what is the sine of 3 pi over 2, as long as we accept the convention that 0 here, pi over 2, pi, 3 pi over 2. Except I'm going to draw a little triangle here. So let's say this is pi over 4 here. This is the positive y direction. This is the positive x direction. If we go to the left, this is the negative x direction, and we go down below, this is the negative y direction. So if I draw a triangle, actually I'm going to do some labeling here. This is the adjacent is positive because it's in the positive x direction. The opposite is positive because it's the positive y direction. And the hypotenuse is always positive. So that's the convention we're going to use. The hypotenuse is always positive, but the opposite and the adjacent can be negative or positive depending on whether the opposite is pointing in the positive or negative y direction and whether the adjacent is pointing in the positive or negative x direction. So if I draw a triangle on the left, say up here, whatever that angle is, if it's in that part of the diagram, if it's in that part of the unit circle, then we're going to have the following signs. We're going to have the hypotenuse is always positive. Doesn't matter what quadrant we're in, doesn't matter what part of the diagram we're in. The opposite, up over here, we're still in the positive y direction. But our adjacent, we're now traveling in the negative x direction, so our adjacent is negative. Okay, and then what happens if we go down below? What if we have a triangle in the lower quadrant? So the adjacent is still negative. The opposite is also negative because it's in the negative y direction. Hypotenuse is always positive. That's going to be our convention. And let's see. Oh, purple. And then the last quadrant here, our adjacent is positive because we're in the positive x direction, but our opposite is negative because we're in the negative y direction there. Okay, so I'm using this picture when describing these special angles because look at what happens at sine of 3 pi over 2. I'm claiming that the sine of 3 pi over 2 is negative 1. And so let's focus on that one. I'm going to draw a little triangle that's inside the bottom right quadrant. It's very close to being that number of degrees. Okay, so this is the opposite side. This is the adjacent side. This is hypotenuse. And then what happens here is as the angle theta goes to 3 pi over 2, the adjacent goes to 0, and the opposite goes to the negative of the hypotenuse. So the opposite, we're in the negative y direction. So the opposite has to be negative. The hypotenuse is always positive. Let's say the hypotenuse is positive 7. then the opposite is going to be negative 7. It has the same magnitude or same length as the hypotenuse, but it's pointed straight down, so it's the negative y direction. So we'd say it's the negative of the hypotenuse. So in this picture, the sine of 3 pi over 2 is going to be, as always, its opposite over hypotenuse. But the opposite becomes the negative hypotenuse at that angle. So we have negative hypotenuse over positive hypotenuse, which is going to be negative 1. So that's where that comes from. And I don't want to belabor all of these, what I'm about to show. Just know that they come from this type of thinking, this type of process. We do the same analysis for the cosine function. Cosine of 0, cosine of pi over 2, and cosine of pi, cosine of 3 pi over 2, and come up with these conclusions. Cos of pi is negative 1, cos of 3 pi over 2 is 0. Now, this trig identity is something I'll describe later on. It's not hard. You probably did this already in grade 10 or grade 11. The tan function can be alternatively, instead of being defined as opposite over adjacent, it can be defined as sine over cos. And if we use this construction, that tan of x is sine of x over cosine of x, then if we want tan of 0, we can just take sine of 0 and divide it by the cosine of 0. So 0 over 1, which is 0. If we want tan of pi over 2, well, that's going to be sine of pi over 2 over cos of pi over 2, which is 1 over 0, which is undefined, as we already described in a previous video. You can get the rest of the tan evaluations at pi and 3 pi over 2 using the same process. What about those other special angles? So far, this is just 0, pi over 2, pi, and 3 pi over 2. What about pi over 6? What about pi over 3? What about pi over 4? The best way to construct those is by using two special triangles. So in the special triangle that's shown here, what's being done is, since the sum of the angles in a triangle have to add to 180 degrees, and if our triangle has a right angle in it, then those two remaining angles, if they're the same, if we make those two angles the same, they have to add up to 90 degrees or pi over 2. And then since they're adding up, since they're the same, then they have to be half of that each, which is pi over 4 each. If we make the shortest side equal to 1, because the angles are the same, the sides opposite those angles must also be the same, so the other side must be 1. And then Pythagorean theorem would require that the hypotenuse is root 2, since the bottom side squared plus the side going up and down squared has to equal the hypotenuse squared. Rearrange, get the hypotenuse all by itself. So that's one of the special triangles. The other special triangle, I won't go through how it's put together, but it's similar, is a special triangle where instead of the angles being equal, we have one angle being double the other angle. So one of the angles is pi over 6, and the other angle is twice that, 2 pi over 6, which is pi over 3. It all adds up to 180 degrees. If we make the smallest side 1, works out that the other side is not half of that or double that. It's a weird ratio, it's root 3. And then Pythagorean theorem tells us that the hypotenuse is going to be 2. So we'll just take these two triangles at face value and then use them to come up with the sine, cos, and tan at these other special angles. So these are just example calculations. I have a worksheet that you can use just to check if you know how this works for other special angles. Let's say I want sine of pi over 4. So I'm going to circle that pi over 4 as my reference angle. Then the opposite over hypotenuse calculation becomes opposite is 1. Hypotenuse is root 2. So you get 1 over root 2. Here's another example. I'll pick this pi over 3. I'll take sine of pi over 3. Sine of pi over 3 is opposite over hypotenuse. So the opposite is root 3. Hypotenuse is 2. What about cos? What about cos of pi over 3? Cos is adjacent over hypotenuse. So the adjacent, the side that's not the opposite, not the hypotenuse, is 1. Hypotenuse is 2. So 1 over 2. We'll do tan of pi over 3. We have opposite over adjacent. So root 3 over 1, which is root 3. And I should throw in a tan of pi over 4. So opposite over adjacent, which is 1 over 1, which is 1. So tan of pi over 4 is 1. Okay, and then I'll pick on the pi over 6 and do a few of those. Tan of pi over 6, opposite over adjacent, so 1 over root 3. Okay, and then one more. Maybe I'll just do 2 more. Cos of pi over 6, adjacent over hypotenuse. So reference angle, the orange is now the reference. The adjacent is root 3. Hypotenuse is 2. And then sine of pi over 6, opposite over hypotenuse. So 1 over 2. I might as well do the last one. I said I was going to do them all, but hey, I'm a liar. Cos of pi over 4 is the last one. So the reference angle, still I'll use the bottom left in that first triangle. So cos is adjacent, which is 1, divided by hypotenuse, which is root 2. Okay. So that's how we would use those 2 special triangles to come up with the sine, cos, and tan of those special angles. So in terms of formula sheets, if you're allowed formula sheets, I'd write down, to save space, just the triangles and maybe the acronym SOHCAHTOA, and that's enough. That's all you need. And that's just that same thing. And I'll continue with the cast rule in the next video.